You, yes, you should please consider taking a look at my Twitch channel at twitch.tv/romogenes, which is where I stream like chess games. So I'll put a link to that in the description. Please consider taking a look. But today, we're going to be doing Advent of Code Day 8. Advent of Code is basically someone releases 2 puzzles every day in December up until Christmas to count down the days to Christmas. So this is just a very fun, month-long challenge. So today, we're going to be doing Day 8, Handheld Halting. Your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, you are interrupted by the kid sitting next to you. Okay. Their handheld game console won't turn on. They ask if you can take a look. You narrow the problem down to a strange infinite loop in the boot code, your puzzle input of the device. You should be able to fix it, but first you need to be able to run the code in isolation. The boot code is represented as a text file with 1 instruction per line of text. Each instruction consists of an operation and an argument. ACC increases or decreases a single global value called the accumulator, given by the value given in the argument. Jumps to a new instruction relative to itself. NOP stands for no operation. So, I didn't read all the details here. If you want to read them, I'll have the link to the puzzle in the description. Okay. So, consider the following program. The instructions are visited in this order. Okay, and then it gives an example. This is an infinite loop. With this sequence of jumps, the program will run forever. The moment the program tries to run any instruction a second time, you know it will never terminate. Immediately before the program would run an instruction a second time, the value in the accumulator is 5. Run your copy of the boot code. Immediately before any instruction is executed a second time, what is the value in the accumulator? Okay, so this doesn't look like too difficult of a problem. So I suppose what we're going to be doing here is just doing a simulation. So I'm just going to copy all of the text over here, and I know I could do Control A, but it's just for fun. Okay, so we're going to paste that in here, and we're going to solve the problem. Okay, so we have arrived at an answer, and our answer is 1723. Okay, that is the right answer. Okay, so I will explain how I did this. Okay, so basically, this is pretty straightforward simulation problem. We are given our input, which is a series of commands, and then we have to execute these commands until we see a command twice. How we keep track of that is we basically have a set where we keep track of the line numbers of the commands we've seen so far, and we put them into the set. And then if we see another number, if we execute a command whose line number is already in the set, then we know we've done it twice. Basically, we just keep track of which ones we've seen. Okay, and then the more complicated part, I guess, is the actual logic of the program. We have to define the inputs. The problem says we have to define an accumulator, a global accumulator, which is an integer, and then we also have to keep track of a pointer, which is which instruction we're executing currently. Okay, so we have this function to just execute a single line. So we do casework on the operation. If it's ACC, then we accumulate the accumulator. And it turns out that Python can actually stringify strings like +3 into just 3. So I didn't know that before, but now I know that. Okay. If it's JMP, then we increment the pointer instead of the accumulator. And then otherwise, no operation, we just increase the pointer by 1. That's basically it. And then the rest of it is just making sure that we don't do 1 twice. And if we do, then we end it, and then we print the value of the accumulator. Okay, so now we're going to do part 2. After some careful analysis, you believe exactly 1 instruction is corrupted. Somewhere in the program, either a jump is supposed to be an NOP or an NOP is supposed to be a jump. No ACC instructions were harmed in the corruption of this boot code. The program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly 1 JMP or NOP, you can repair the boot code and make it terminate correctly. For example, consider the program from above. If you change the first instruction from NOP +0 to JMP +0, it would create a single instruction infinite loop, never leaving that instruction. Okay. Okay, so if you change any of the JMP instructions, the program will still eventually find another JMP instruction and loop forever. However, if you change the second to last instruction from JMP-4 to NOP-4, the program terminates. The instructions are visited in this order. After the last instruction, the program terminates by attempting to run the instruction below the last instruction in the file. With this change, the program terminates and the accumulator contains the value 8. Fix the program so that it terminates normally by changing exactly one jump to NOP or NOP to jump. What is the value in the accumulator after the program terminates? Okay, so I think this is a pretty simple problem, but we're just going to do it, all right? Okay, so we have arrived at an answer, and our answer is 846. Dang, okay, we got that right. Let's go. Okay, so now it's time for me to explain the problem. Okay. So this is pretty similar to the first part, except now we have to define like this function, which is to run a program, and this is like the entire definition. So a program is basically just like the list of lines that are in the program, and we have to do this because we're going to have to test multiple different programs. So running the program just involves basically what we did before, except we defined the executing instruction thing. This is the same thing, except we just modified it to return the increments in the accumulator and then the increments in the pointer, just to make it easier on like global variables and stuff, because I was doing a bunch of errors and I didn't like that. So just modified that, but it's the same thing. And then over here, the loop is a little bit different. So instead of checking to make sure that nothing repeats infinitely, we also make sure that the pointer doesn't exceed the length of the program, otherwise that's going to return an error, right? So after this thing ends, after the while loop ends, we know that all the proper instructions have been executed, but that means either an infinite loop was seen or the pointer exceeded the length of the program. And the problem tells us that if the pointer exceeds the length of the program, that means that we're done, because it tries to access an instruction that doesn't exist. And that means we're done. So if that is the case, then we can assume that it's done, and then we can just return the accumulator. Otherwise, it's an infinite loop, and then we return none. Okay, so that's the program. If it's infinite, it returns like null, and if it ended properly, then we return the accumulator. And then basically what we do is we brute force this. We go through every single line in the program. We modify it if it can be modified based on the rules. We modify it, run the modified program, and see if it produces a good result. If it does, then we're good and we're done. Otherwise, we're not, and then we move on to the next line. So basically, we're tweaking every single line to see if it works, and if it does, then great. But we're just trying to find the line tweak that works, and we don't actually need to identify which line needs to be tweaked. We just need to identify the answer after that line is tweaked. And how we do that is basically a simple if-else switch. If it starts with ACC, we know that no ACC lines have been modified, so we can continue. But if it's NOP, we modify it to be JMP, and if it's JMP, we modify it to be NOP. And then we run the program and then see if it works. So that's basically today's puzzle. I think this one was a little bit easier than the previous ones, or at least it was easier to explain. But also just not as complicated a problem, I think. But, if this was a challenging problem, hopefully this video helped you. If it hasn't, or if you have any other feedback, please leave it in the comments. And that's basically it. I'm going to have a playlist for all the previous videos and hopefully all future videos. That's going to be linked in the description. And also all the code that I'm writing here is going to be available in a public GitHub repository, which I'm going to put the link to down in the description. So yeah, thanks. Tomorrow I'm going to be back with day 9. Stay tuned for that. If you really want to get notifications, you can always subscribe and push the notifications button. But just watch out for day 9. And thanks for watching. I'll see you tomorrow.